Hello, we're going to talk about Module 5. Module 5, we're going to learn about conditional statements, which we already looked into with if else. But another part of conditional statements is Boolean operators. And cases is another important part of creating a code. And if this is the case, do X. If this is the case, do Y. So Boolean operator, cases, and conditionals are connected. Then we're going to talk about lists, arrays, and templates. We have talked about arrays and vectors and matrices by now. Now we're going to see the true definition of lists, arrays, and templates. And we are going to be looking into homework 5. So Boolean operators. In Boolean operators, you can think of Venn diagrams where A is a group of objects and B is another group of objects where A and B have a union or a common set of objects, but A not B is all the group of objects that have not properties common to B. A and B are the objects that had both properties of A and B and are connected in an intersection. Then we have X or, which is either or, so properties of A or properties of B, but not the properties of both at the same time. And then we have the X and or. So X nor is everything except for the properties of A or the properties of B. So all the universe of things are acceptable as long as they don't have properties of A, and all the universe of things except the properties of B are accepted, and those things that have properties of A and B are also accepted. So these are the cases where controllers and actuators use to control operations and processes. So another application of Boolean operations is in geometry to create regions. So the union of two objects is, for instance, this cube and that cube. The union will make them kind of like soldered or glued together. The difference is depending you use as the base and which one you use as the second phase or the second region, one will subtract the other. So in this case, the yellow cube is going to be the base or primary, and the green cube is going to be the secondary. So the secondary is subtracted from the primary, and the primary stays. Therefore, the difference between region A and region B is this object. For example, the shapes A and B have A but not B will be this blue region, B but not A will be the circle with the blue region. A and B, also called union, A union B is both elements. A intersection B is this part where they intersect, and A but not, or A, X, or B is everything that is part of A and everything that is part of B, but not the intersection. As we saw before, a common way to implement Boolean operations is by greater than, equal than, or less than. In this case, everything that is less than the yellow cube is subtracted from the yellow cube as such. So less than is a good condition to implement for cases where you want everything to happen except for things that are greater than X or Y or Z. Same thing with greater than. So everything in this group can happen except for when X is greater than that threshold. And equal to is pretty common by now because we've done if else examples with equal to. Be aware that equal to could become tricky because it has to be exactly equal to 9. So 9.1 is not the same as 9. Therefore, make sure that you understand that has to be exactly the same. In fact, 9.1 and 9 fall into the greater than or less than category. Another important case or topic is the switching case. So as we saw before, you can create switch case and execute a block of instructions by the switch case commands. So switching case can be used where different alternatives can happen. And the value of the expression is compared to the values of each case. You can use break or returns to stop the code. So let's look at this example. New source file. And for that, we're going to use the include IO input output stream. It's because we're going to use console out or C out. And since we're going to use C out, we're going to use the namespace standard. Now we're going to create a main function where we're going to ask the compiler to return a 0 if everything's successful. And then we're going to create our code. So let's call this character operation. We'll define the character is not initialized yet. And we're gonna declare some float numbers, num1 and num2. So we can print out the following. We can say enter an operator. And examples of operators are summation, subtraction, and we have also multiplication and division. Now, when they input an operator into the console, and we're just going to call that operator. So we're going to take it as a character, and we're going to say enter two numbers. So we can actually copy this line, and we're going to say enter two numbers. So let's say, so you have two options here. You can say enter first number and bring it to num1, and then enter second number and bring it to num2, or just ask the user to input both numbers at the same time, and they're gonna come and locate it. They're gonna be assigned to num1 and num2. Okay, so far we should have no errors, and we need to create week 5 executables. And then in this case, we're gonna call this case example1, and we have one error that is standard and using namespace standard. And then we need to write a semicolon and then say operation end of line, cin, no match for operation. And I'm wondering why this is not match for operation if it's this declared up here. End of line, and the error says no match for operator. Let's see what's going on here. Oh, yes, the error is that I am telling cin is I'm not telling cin that you need to take this value and save it in the operator character. Okay, that was the error. Now, so far we have two numbers. Excellent. What we need to do next is that we need to use the switch case syntax. Switch, and then we're gonna use operation to create our logic. So curly bracket open and curly bracket close. So case 1 is going to be for summation and column, and then the sign here is, what are we doing here? We're saying that num1 plus num2 equals, oh yeah, so we can say for case 1 we can say console out and num1 plus num2 equals num1 plus num2. Very well. I should have no completion errors, and I don't. In this case, we're going to borrow this, and we're going to say case 1. For case 2, we're going to say subtraction, and num1 minus num2 is num1 minus num2. Okay, we're going to say that the next one is multiplication, and then num1 times num2 equals num1 times num2, and then we can do the last one, which is division. We can say that num1 divided by num2 equals num1 divided by num2, and here we're going to stop this with a break, and we can also use a default. So we can use default. If none of those cases happen, then we can say cout, end of line, and in the middle we're going to write a comment that says error, the operator is not correct, in case the user inputs an ampersand or something different. Okay, so let's try to run this, and what happens if we run it? Enter an operator. So let's say plus, enter two numbers, 2, 3. Oh, it's 2, enter 3. So plus 2, enter 3, enter. So 2 plus 3 equals 50. Well, that is not true. Let's see why it's not doing my case. So the operator is plus, and this should be plus with, and that is because I am not using the break. So it's running every single case, and the key is to ask to go into the case and then break the sequence. And in this case, it should work. So execute it. The command is plus, the character is plus, and then 2, enter, 3, enter, 2 plus 3 equals 5. Excellent. Let's try one more time. Let's say it's going to be times, multiplication, 2, enter, 3, enter, 6. Excellent. And when I type a character that is not used, then it's going to tell me error, the operator is not correct. But it's pretty simple, because then by now we know that we can add that case as well. And for that, all we need to do is add the case like so, where the operator is here, and we can actually include CMath. Let's see which library has the power. Is it CMath or standard? Let's try CMath first. So if you type hat, that will mean that we want to type power of num1 comma num2. Let's see if this works. No errors. So the operator is hat, and 2 enter, 3 enter, and they should give us 8. So 2 times 2 times 2 equals 8. So that works. And what I did was that I included the power function from the math library. So if you remove this library, then the code is going to be confused, because as we talked before, the functions are in this mathematical library called CMath. Another thing that you could do is they use, let's see if it's downloaded with Dev++. Yes, math.h. And math.h should be part of your installation, which also works. So math.h is the library exclusively used for C++, but since C++ is based on top of C, then CMath will also be okay. So you can use CMath or math.h. Let's look at another example. It's the same thing, where we can use a break in a case and switch. So in this case, we're going to use a similar example, but first of all, let's create a new file. And for that, of course, we're going to use the include input output stream, because as we mentioned before, we're going to use the cout. And since we're going to use the cout, we need to use the namespace standard. Then we create a function called main, and we need our curly brackets and return 0. All right, we're good to go. We can do that, say, well, you can ask the user, or you can declare the number of the day here, and say the 4th day of the week. And then we're gonna switch our case based on the day. So remember, before we were gonna switch based on the operator. Now we're gonna switch based on the day. So switch day, curly brackets, close brackets. When you end your switch, which is all the way over here, you can have a default or not. So in this case, since we only have 7 days, we don't need a default, because the goal is to have all 7 days written down as cases. So case 1 with column, not semicolon, is going to be cout and Monday. And we're going to do the same for everything with different names. So case 2 is Tuesday, and case 3 is Wednesday, case 3 is Wednesday, and case 4 is Thursday. Case 5 is Friday, and and case 6 is Saturday, and case 7 is Sunday. Very well. Now we are forgetting the break, therefore we need to type break after each case, since the goal is that enters the case and then exits the program. And then, yes, we have all the 7 cases there for break and return 0. So if we do that, call it case example 2, run it, compilation error, switch day, and it's because I am not writing switch correctly, and then no errors. So day number 4 is Thursday, right? So evidently if you're going to change here to 7, then you're going to have day 7 is Sunday. But if you type here 10, what would happen is that, again, run it, and then instead of 7 we're going to have a 10. Compile, then nothing happens because we don't have a default. So in our default we can do that default if int is greater than 7, then do 7 minus 7. So for instance, if you type 8, 8 minus 7 is 1, so it will be back to Monday. So you can do that. Now we can talk about arrays. So remember that arrays are a collection of objects that share the same data type. Therefore, if you have a collection of ints, the array can hold ints throughout. If it's not the same data type, then it's not an array. It would be something else, a dictionary, or it could be even a list. Arrays have a beginning point and an ending point. So this particular array has 4 elements, so the size is 4. 1, 2, 3, and 4. The beginning of the array is 17, which has position 0. And the end of the array is 12, and the position is 3, because 0, 1, 2, and 3. The size is 4, beginning position is 17, end position is has that number 12. Arrays could be also accessed through pointers. So let's say you can call the initial array of position is 5. This is 0, 1, 2, 3, and 4. But the total amount of elements has 5 positions, so 5 elements. And if you create an int called int pointer, and this is equal to the array name, so now the pointer points to the array. So when you say point IP equals 2, points to the first element of the array. So this is a 2. Therefore, you can keep adding pointers. So say pointer plus plus, and say next pointer position is going to be a 3. So you can add a 3. And next pointer position is a 4. So you can add a 4. So arrays have, remember, a beginning, an end, and a size. And you can populate or fill up your array using pointers. The way you declare the size of the pointer is with this type of bracket, close bracket. So let's look at this example. New file. And now since we're going to use printf, not cout, but printf, we're going to use standard input output.h. So first of all, include our library, standard input output.h, int main, and obviously we're going to do a return 0. So the first thing that we're going to do is floats. So a float of high score 1, We need 5 of them. So 5 score 1 equals 993.86. High score 2 is going to be 688 or 682.01. The third highest score is 639.60. And we have the fourth one with 310, about 0.45. And the last one is 123.25. So let's go ahead and say, we're gonna put a comment up to the screen where we type here are the highest scores or test scores, and then we can do printfs. Printf, remember there, printf is if you're gonna type something to a file. Just printf by itself is gonna print to screen. So we know that we're gonna be typing first high score 1. Remember, when you declare the variable, you should not have any spaces. That is a big no-no. We want to have no space. And the text is going to be score 1. And since we have floats, what we need to do is type float with 0.2 or with 2 decimal points, and then jump line, right? Array, example 1, and this is 4, and this is 5. So printf score number 1 percent, oh, it's not 0, sorry, it's 0.2. High score, and then we have the semicolon. Printf score number 1 percent to f high score 1, and then the error is because of the semicolon up here. Good. And then we would have to do this so many times. What is it? 5 times. Because we don't have an array. We're just doing this hard coding it. So it's time consuming and not very efficient. But you see that it's simple and you can get your values printed pretty easily. And number 5 is, okay. So if we compile this with no errors and we run it, then the highest scores are right here. All right, good. But now what we want to do is perhaps we can add those to an array. So instead of defining 5 different variables, we're going to define one, and it's going to be an array. So let me copy some of this so we can create a new code. Since we're going to use printf, we're going to keep the same standard.h. We're not going to use cout, therefore we don't need the namespace standard. What we do need is float high score with position 5. Okay, so now what we need to do is, first of all, it's already defined as a float. Therefore, we don't need to define more float. What we need to do is define the positions of the array, which in this case is going to be the first one, so high score at 0 is this, at 1 is this, at 2 is this, at 3 is this, and at 4 is this, for a total of 5 positions, right? As we saw here, is going to be size 5. Now, to print this, we simply have to say score number 1 is also going to be a float, but now it's going to be a position 0. Then it's going to be position 1. Then it's going to be position 2. Then it's going to be position 3. And then it's going to be position 4. So if you run this example again, you should have the same results that we got before. But this time we're using an array, and the array is organized with a float type variable in each position. But this could be further optimized. We can create a for loop to print the scores. And in that case, we can do this example. So pretty much I can copy the whole thing again and create a new file. And the only thing I have to do is remove the printing sequences, printing lines. And I can do for e, or int I, equal to 0, because we're starting from position 0, where I is less than 5, and we want to do I incrementing 1 by 1. What I want to do, I don't need the curly brackets because I only want to put one line. What I want to do is I'm going to say print f, semicolon, and then we're going to have the comment and the variable. The variable is high score. Variable is high score I, and we just type the so for instance score number, and then this is going to be an int, so %d, and then we're gonna say equals, and then the float, so %, 2 decimal places, and f, and then jump line. So this part, all it is that we're printing a float type, but we want to print 2 decimal points. So if we run this, and we call this example 3, we have no errors, and we run it, and we have 0, 0, 0, 0, and that is because we are not accessing high score I. Why do we have zeros if we want to plot high score? Oh, yes, because need I, comma, the first one is going to be my int, and the second one is going to be my float. So in that case, there you go. I have the same answer that I had before. And if before was 1 through 5, we just do +1. Because remember that before we had 1, 2, 3, 4, 5, versus now we have 0. If we run it again, we have a score 0, 1, 2, 3, and 4, which whoever knows C and reads this, he understands, oh, okay, this is a C program. But perhaps you want to show it on a bulletin board starting from 1. So all you do is just add 1 here. So now we have the same as before. If you want to ask the user for the numbers, you can use something similar to cin, to console in. We can use scanf, or you can use cin and save it in a variable. But in that case, what we want to do is something similar. So say this is a program for a teacher to input the scores based on the order of largest to smallest. So let's create a new file, and then we're going to include standard input output.h, so we can use printf. And then we're going to create a main function, return 0. And what we want to do is create an array, float scores. And it's going to be five positions long. And we're going to create another int. There was going to be a temporary variable. It's going to be temporary, where we're gonna just basically store the variable from the user and then put it into the array. So for that, we can say for int parentheses for int I equals 0 semicolon. I is going to be less than 5 because that's the size of. In fact, we can do something else. We can do int size equals 5, and then put here size, and then size. So int size equals 5, and we have what does it mean? Oh yeah, I++. Then what we can do is say printf parentheses semicolon. We have a comment and a variable, and the variable is going to be the number of the score. So first score, 0 plus 1 is first score, and we're going to say type score number %d, number 1. All right, that's very good. Let's see so far we have any errors. So far we should have no errors. And then wherever the user types, we're gonna read with scanf. So we read with %f because it's a float, or it could be any number, 86.1 or 100. And then that is going to be appended or taken to the array called scores and position I. Let's see if we have any errors. Very well, no errors. Let's see then. We type to string puts. Here are the scores. So here are the scores. Good. Semicolon. And then we just basically do another for loop where we print the array. So it's going to be printf. Well, we don't need this bracket. Printf semicolon. We need a comment, and we need the variable. So the variable is going to be scores I, and we're going to be printing with 2 decimal places a float. Okay, and the text is going to say score number %d equals, and in that case we need to add I plus 1 comma. Let's see so far what we get. So score 1 says 99, score 2 91, 3 is 85, 4 80.1, 5 78.8. So he types that. Another thing that we can do actually is, instead of changing this, if this is truly for a teacher or for a class, we can say, after all, let's say include input output standard or stream, and using namespace std. And then what we can do here is int size, but we don't initialize it. And what we can do next is cout and line, and the comment is going to be type the number of scores. And then what we can do is cin with the proper casting or the proper flow to size. And in that case, we remove this comment, this line of size, and we create the array with the size that we design or we want. So cout type what is going on that IO stream. But I did have a mistake. The direction of these arrows are important. Cin is taking the value to size. Okay. All right, good. Run. Type the number of scores. So let's say the number of scores are 4. There are 4 students. Enter. Score number 1, 99, 89.2, 87.5, and 85. So notice that it doesn't really matter if it's largest or not. In this particular case, we can later create another function to put or write the largest first or whatever. We can type them in any order